So with that, I'll turn this over to Tim Schofield to talk about the ASI
Thank you.
situation.
Whilst all these great images were coming down this afternoon, we were having our own excitement on the ASI Met, verging on nervous breakdown. We planned to deploy the mast after the first high-gain downlink, after we'd expected the pictures that were displayed. We found to our dismay that we couldn't see the mast in the pictures that came down due to a slight difference between the testbed hardware and the actual flight hardware. An object near the camera was obscuring the view of the mast, so we had no means of telling whether the airbags were blocking the mast deployment or not. We have very delicate thin wire sensors on these masts, and even brushing against the airbags would tear these sensors. We delayed any action until the second downlink, where after the Rover petal manipulations, and there the pictures were just a little better and allowed us to see the bottom corner of the mast, and that would look clear, and other indirect information persuaded us that the mast itself was clear of the airbag, which probably wasn't overlapping the petal, and this indication was also strongly reinforced by the mission manager, who reminded us that he was losing 20 or 30% of his solar power from the panel whilst the Met mast was down. So we decided to deploy the Met mast on what information we had, and in the final downlink, the last packet received in the final downlink showed the Met mast had deployed. Some images showed the mast vertical, and we had one data session in the fully deployed position. All of our sensors are working correctly, and the first figure shows the Viking temperatures with a few of our sessions average superimposed on that data. Only the last point, this point here, is with the Met mast deployed. Before this time, all the temperatures are very much higher than Viking, almost at freezing point here, 32 Fahrenheit. When the mast deploys, we're looking higher in the atmosphere, a meter above the surface rather than a few inches. The temperature drops down much closer to the Viking level. Should remind you that Viking was making measurements at 1.6 meters, so we would expect to be a little warmer than Viking during the day, because we're still close to the surface. So this is 1.6 meters, this is 1 meter, and this is a few inches above the surface, and it sort of gives you an indication of how the temperature is varying with distance from the surface. As we'll get no more data today, tomorrow afternoon we should expect to see an entire daily cycle in our data set and get a good comparison of the daily cycle on Mars. The next image shows same data for pressure. Pressure is not influenced by the mast deployment. That's taking measurements out in a completely different location on the spacecraft. And we were astounded by the agreement between the measurements we'd taken and the old Viking data. We have much more resolution, but we seem to follow pretty much down this Viking curve for this time of the day. The last point is about 1:45 in the afternoon. We have preliminary wind measurements for this last point in the mid-afternoon. The wind is blowing from the east-southeast. It's very light, a few meters a second at the most at that particular time. Tomorrow we should be able to produce time variations overnight and during the most of tomorrow of the variation of wind. So after a bit of nail biting on ASI Met, we're all now feeling very pleased that we're seeing good quality data coming back. Thank you.
Just one more thing before questions, to give you some idea what we're expecting tomorrow. We obviously will try to get the rover off by the imaging tasks we've already talked about. We also will almost certainly not deploy the IMP on its mast this evening and wait until tomorrow to take a series of panoramas additional to the ones you saw on NASA TV coming down this evening. We now have a panorama in that one color, but we would like to get panoramas in other colors as well prior to deploying. So we will maintain the imager in its state. We will continue to take weather data, and we will try to get the rover off.
Okay, we've all had a very full day, and many team members have to do yet more work, so we'll try to keep the Q&A session fairly brief. Let's start over here with Casey.
Hi, I'm sorry, I don't quite understand how you're going to be trying to communicate with the rover or recycle, do things this evening. Hasn't the Earth set, and can you give us a little time schedule for tomorrow when things might happen, Earth time, and what time, when that is on Mars?
Sure.
Thanks.
I'm sorry, I didn't mean to be obscure here. The rover is actually running the first sequence that it received this morning. That sequence contains commands that actually are executed overnight and tomorrow morning. During the course of the execution of those commands, it routinely and regularly attempts to communicate to the lander. Now, those commands are synced up with other commands on the lander, which bring the LMRE, the lander's modem, online for communication with the rover. So the sequence of activities is such that the rover is, over the next several hours, will be continuing to attempt to communicate with the lander. Overnight, the rover will shut down and wake up hourly, continue to attempt to communicate with the lander, and this will go on through really through the rest of the morning as well. The command sequence that's on the rover right now actually runs into day 3. Runs rather benignly in that regard, periodically just communicating health check information, health status information concerning the rover. The sequence of events that will take place tomorrow start roughly with the first downlink that is coordinated with about 8 or 9 o'clock. I believe it's actually 8 o'clock a.m. local time on Mars, which is roughly about 4 o'clock 4 o'clock in the afternoon Pacific Daylight Time. And then we proceed from there through what is something like what took place today. There'll be opportunities during the course of the remaining evening and into the early, into the night, where we'll have opportunities to be able to command sequences to the lander to be sent to the rover. We'll have perhaps some other activities to perform both on the lander and possibly also on the rover to try to clear this problem. And that's those sequences and those activities what we'll be talking about building tonight and tomorrow morning.
Okay, Todd?
Todd Halverson of Florida Today for Jake. I'm wondering if you could give us an idea of when you think the earliest the rover could roll off. And for Mr. Schofield, I'm wondering if you could tell me again what the temperature was in Fahrenheit and what the wind speed was that you saw in your data.
Okay. I believe the earliest we'll be able to roll off tomorrow will be something on the order of about 7:30 tomorrow night. That's local, that's Pacific Daylight Time.
Okay. I'm sorry, there was a part two.
On the temperatures, after the mass deployed at about in the heat of the afternoon at about 1:45, we showed on our top mass sensor about 1 meter upper temperature of about 255 Kelvin, which corresponds roughly to about 0 Fahrenheit.
Okay, want to get the microphone to Bill Harwood?
Just scared me. Bill Harwood, CBS. Is there any idea what the possible causes for the garbling between the modems? Have you seen a signature like that on the ground in any testing? I mean, or is this a complete unknown at this point?
We haven't seen it for some time. There is some indication. We've been polling our engineers, and they've been kind of going back through their activities, their notes and such, that we've seen a variation of this, where the two modems clocks are out of sync for one reason or another. We think the power cycling is a means of clearing that. There may be other ways of attempting to clear the problem, which we think is on the lander side of the interface. But I wouldn't like to speculate here at this point. I don't think we've had a really adequate time to fully diagnose this problem and give you a most likely reason as to why it's occurred.
And a quick follow-up, and this may be a dumb question. I was under the impression from what you said that you see this with big chunks of data going through as opposed to smaller packets.
No,
is that
actually,
right?
no. Actually, we've seen small chunks of data going through. The large chunks of data are not getting through, and that's consistent with a communication rate that's degraded quite a bit.
And that's where I was going with that. Is there, if you never could resolve something like that, can you send commands in smaller chunks and get around that problem down the road at some point?
It's possible to do that. Again, I would prefer not to speculate at this point.
Jim Vocek, CNN. When the rover drives down tomorrow night, do you have a plan at this point where it's going to go exactly?
Okay, in all likelihood, it's going to go down the front ramp. This is what we'll attempt to do tomorrow is consistent with what we were trying to do on the best of circumstances tonight, which is to really do a very short traverse at the end of the ramp, do a turn, roughly anywhere from 45 to 90 degree turn right into an area that's clear at the end of the ramp, and put the APX down to take our first night or first soil measurement overnight on Salt 2. That would be the nominal plan to be performed tomorrow.
Okay.
Eric Simon, Vosaic.com. I have two questions. Number one, if the option always existed to deploy the ramp out of the rear, why was that option not pursued? And question number two, if the modem issues, the communication problems are not resolved, how will that impair the rover's mission?
The problem with the rear ramp deployment is that we didn't get a confirming image on this downlink that showed that the airbag material that was draped over the one edge of the ramp had been removed as a consequence of the airbag retraction and pedal move activity that was conducted tonight. That was the reason why we didn't deploy the rear ramp. Otherwise, the images that we did get of the rear area of the pedal indicates that the airbag material did move, that there does not appear to be any obstruction otherwise of the ramp deployment. We just did not want to risk deploying that rear ramp, given the absence of this confirming image information. Again, I'd like not to speculate as to what would happen if we do not reestablish communications. There are some contingency options that could be exercised in that instance, which will eventually drive the rover down the front ramp and onto the surface.
Leo?
All right, in this live press briefing from NASA in Pasadena, we've heard that excellent data is still coming from the Pathfinder on this mission to Mars. NASA has been successful in pulling back a troublesome airbag that was obscuring one of the ramps for the rover buggy, which is going to be roaming around on Mars doing geology experiments. They have managed to pull that airbag back and under, but they have not yet deployed the rover. We can look for that tomorrow. We heard some glowing descriptions of some of the features of Mars, which are surprising scientists and engineers, even as they're surprising us. More at 3 a.m., more from John Holloman tomorrow morning at 7 a.m. Right now we resume Larry King out of this break.
This has been a CNN Live event.